So we'll discuss Hooke's law exercise today, the questions from the Hooke's law. In question 1, which is related to paper 2, multiple choice questions. You can see diagram 1. In a diagram 1, a bead balance is being used. And a beaker with a wire loop is balanced with the standard masses. And the beaker is then removed and hung from the spring. The spring extended by 5 centimeters in diagram 2. What is the purpose of like the second case? The spring is stretched by a force, or we can also say due to the weight. So the weight is causing this extension. But here what happened in the first one, a beam balance. So mass of a wire with a loop is balanced with these standard masses. And mass of an object does not change when we move from one place to another. So the experiment is repeated with the same apparatus on the moon, where the acceleration of a free fall is less than Earth, like the gravity of the moon is weaker. Which statement describe what happened on the moon? So if we take the same apparatus like diagram 1 and diagram 2, they are repeated on the moon, this will be same. Why this will be same? Because the mass of an object does not change from place to place. So what mass is there on Earth, same mass will be there on the moon, and the beam will be balanced. But what about the diagram 2? If we do the same experiment on the surface of the moon, because the moon is having a weaker gravity, so the weight of the object on the moon will be less as compared to weight on Earth. So if the weight of the object is less, the extension caused by this weight or the stretching force will be smaller, so it will have a small extension. So on Earth, if it was extended by 5 centimeters, on the surface of the moon, the extension will be less than 5. So the beam will be balanced, but the extension will be less than 5. So which is the right answer? The beam is balanced and spring extended by 5. No. The beam will be balanced and the spring extended less than 5 centimeters. So why the beam is balanced? Because the mass does not change. So mass, same amount of, same mass can balance on the moon. But why the extension is less than 5 centimeters? Because the weight of the object on the surface of the moon is less as compared to the weight of an object on Earth. That's why the extension on the moon is smaller as compared to extension on the Earth. So if on the Earth the extension is 5 or extension was 5, on the moon it will be less than 5. Is it a clear discussion? The next question, an experiment is carried out to measure the extension of a rubber band. The results are shown. Which figure is missing from the table? Look, this is a length. It was 15.2. Then the length becomes 16.2. When the length changes from 15.2 to 16.2, how much is the extension? 1. Same thing. If the length is 15.2 and extension, like increase in length, is 2.1. So what will be the total length? If the original length is 15.2 and the increase in length when a load is attached, when the load is attached to the object, the length increases by 2.1. So what is the extension is 2.1. So what is the total length? 15.2 plus 2.1. So that will be equals to 17.3. So 17.3. So B will be the right answer. Because the original length is 15.2. So like this length is 15.2. And when a load is added, the length increases by 2.1. So the question is, what is the total length? So 15.2 plus 2.1 makes 17.3. That's why B is the right answer. A student adds weight to an elastic cord and he measures the length. He plot a graph between the results and as shown. So usually when look, if the graph is starting from origin, So this part is the extension. If the graph was starting above origin, if we have a load and extension graph or a weight and length graph is there, so the graph will not start from origin, it will start above origin. But this should be extension. And how extension is calculated? Extension is calculated by measured length. What is the meaning of measured length? Measured length means like length of a spring with load, and the original length means the length of a spring without any load. So measured length minus the original length will get the extension. So which one is representing the extension? Option D is representing the extension, because extension is the total length or a measured length minus the original length or length of a spring without any load. If the graph was starting from above origin, then what should be the answer? Then we can say the measured length A will be the answer in that case. A spring is suspended from a stand and loads are added, the extension are measured. So force and extension graph should always, like when we add a load, the spring will stretch, the length will increase. So force and extension graph, it should always start from origin, force extension or force and load. So which graph is starting from origin and it increases if we add the load, the extension will also increase. So D is the right answer. A spring is stretched by hanging a piece of a metal. What is the name of a force given that stretches the spring? So which force will stretch the spring? The weight of a metal which stretch the spring. That's why D is the right answer. A student carries out an experiment to plot extension and load graph. The diagram shows an apparatus. X is representing the original length and Y is representing the measured length. How we can find the extension? Extension is measured length. If you want to calculate the extension, it is a measured length minus the original length. So measured length of the spring, that is Y minus X. Like how much it has increased, we can get this extension by using Y minus X. So Y minus X, option D is the right answer. In question 7, objects with different masses are hung on a 10 centimeter spring. The extension of a spring is directly proportional to the mass hung. Means the mass which we hang and extension are directly proportional. If extension is double, the mass will be double. If extension is 3 times, the mass will be 3 times. What is mass M? So how we can work out if 100 grams was attached, like example, when you check figure 1 with figure 2, when 100 grams is attached, what is the extension? It was 10 centimeter, changes to 20 centimeters. So how much the spring stretch, or what is the extension? The extension is 10. So 100 is causing a 10 centimeter extension. Now, when a mass M is attached, how much is the extension? Extension is always calculated from the original value. Like originally it was 10 and now it is 30. So how much it has extended? So it increases by 20. So extension is equals to 20 centimeter. So we just cross multiply. 100 cause 10 centimeter extension. So 20 centimeter extension is caused by M. We cross multiply. So it will be 100 multiplied by 20 divided by 10 is equals to M. So 0 cancel with 0. 100 multiplied by 2. That's equal to 200 gram. So 200 gram will cause the extension 20 centimeter. And if 100 is causing 10 centimeter extension, so as it is directly proportional, 200 should cause 20 centimeter extension. This is the extension and load graph is there. The unloaded length of a spring is 15 centimeter. So when object is hung, When nothing was attached to the spring, it was 15 centimeter. When a load is attached, any load is attached, the length of a spring is 16.4. We want to find how much load is attached. So first, 15 centimeter is the length of unloaded spring and 16.4 is the length of a loaded spring. So how to know its extension? Like increase in length. So it is 16.4 minus 15. 16.4 minus 15, that's equal to 1.4. So 1.4 is the extension. Now, using a graph, if the extension is 1.4, what is the load? So how we can work out 10 boxes equals to 1. So each box is 0.1. So this will be 1.1, 1.2, 1.3, and 1.4. So we'll draw a line from 1.4. And we find the load. So this is 3.1, 2, 3, 4. And this 3.5. So this is 3.5. So C will be the right answer. So first, the length of unloaded spring was 15 and the loaded spring is 16.4. We find first the extension to know, because the graph is between extension and load. So using the graph, we work out that if extension is 1.4 and from 1.4 we find how much load is attached. So when the extension is 1.4, the load attached must be 3.5 newtons. That's why C is the right answer. Question 1 from the structure question, state Hooke's law. So a common question, how you define a Hooke's law? You can say extension of a spring is directly proportional to load. The extension directly proportional to load, that's the Hooke's law. Then for a force up to 120 Newton, the spring obeys the Hooke's law. When we apply 120 Newton, it should be a straight line as it is obeying a Hooke's law. A force of 120 Newton cause an extension of 64. On a figure, draw a force extension graph up to 120. So 10 boxes equals to 50, each box equals to 5. So this is 105, 10, 115, and 120. So this is 120. And 10 boxes equals to 20. So each box is 2. So this will be 62 and this will be 64. So 64, extension is 64. And the force is 120. Because it is obeying a Hooke's law, so, and it's an extension force graph, so it will be a straight line. So till this point, we'll have a straight line passing through origin. Then calculate the spring constant. How we can calculate a spring constant? For a linear region, for a straight line part, you can take any value of the force and respective extension and just divide them. Any value you can take or any point you can take. Like example, if I'm taking even the last point, you can also take the last point. According to this last point, the force is 120 and the extension is 64. So 120 divided by 64, which is 1.9, and the unit of the force is Newton, and the extension is given in millimeters, so it will be Newton per millimeter. You can take any value, it's up to you on a linear part. Find take any point and respective value of the force and the extension. You just divide them and you get the value for spring constant. Then student makes the spring balance by using a spring in B. The maximum reading on this balance is 150. The student tested the balance with the known weight of 140 and he observed the reading is not 140. Suggest and explain why the reading is not 140. Look, what might happen, because till 120 we know it was obeying a Hooke's law. Like it was, if you increase the force, extension was also increasing with the same rate. But when a student uses as a spring balance, the spring is used to make the spring balance, and he add a load of 140. So maybe the load of 140, the spring does not obey the Hooke's law, or the extension is not directly proportional to the applied load, or spring may cross the elastic limit. 2 marks are there. So at force of 140, the spring does not obey the Hooke's law. Or we can also say it crossed the elastic limit. And one more point, sometime we have to complete these type of graphs, like if it is obeying a Hooke's law or no, like it was it was obeying a Hooke's law. Then when we add a load, when we add a force, so increasing a force, if the extension on y-axis, what will happen? The graph will shift, like diverted towards the extension axis. If the extension is, like in this case, extension is on x-axis, so the graph switch towards the x. But if extension is on y-axis and the load is on x-axis, and we want to complete a graph beyond the limit of proportionality, so it will be a straight line, and then if we increase further force, the extension will increase, so with a greater rate, so it shifted more towards like y-axis. So it depends on if it's like shifted towards the extension axis. If extension on x-axis, it will shift towards x-axis. If extension on y-axis, it will shift towards y-axis. Like this is another thing you should know related to the question. They can ask like complete a graph beyond the limit of proportionality. So you will always complete in towards the extension axis. In an experiment, forces are applied to a spring as shown. The results of the experiments are there. What is the name given to a point Q? Point Q is the last point where it is obeying a, like it's a straight line region. So we can say that is a limit of proportionality or proportionality limit. For a graph part OP, the spring obey Hooke's law. What is the meaning of Hooke's law? Like if a spring is obeying a Hooke's law, what does it mean? It means that extension of a spring is directly proportional to applied force. Or extension and force are directly proportional, we can say. A spring is stretched until the force and extension are shown by point R on the graph. Compare how the spring stretches as shown by part OQ and QR. So two parts are there of the graph. One is O to Q. Another one is Q to R. So how we compare O to Q? So O to Q, we can say it obey the Hooke's law. And from Q to R, it does not obey the Hooke's law. Or we can say here, force and extension are directly proportional. Here, force is not proportional to extension. Then for part OP, find the value of a K. So from O to P, only this region they ask to calculate the value of the K. Again, you can take any point on this. If I take point P, so this one is the force. And we have the extension. So spring constant is force divided by extension. Force equals to 8 and extension is 2. So 8 divided by 2. that is 4 Newton per millimeter. So 4 Newton per millimeter is a spring constant. Then state Hooke's law, again the same, that extension of a spring. Proportional to or directly proportional to the load of force and extension are directly proportional. Figure 1.1 shows a graph for a stretching force acting on the spring. State the feature of the graph that it shows that it is obeying a Hooke's law. Like from the graph, how we can say it is obeying a Hooke's law? Number one, it is a straight line with a constant gradient or straight line passing through the origin. So these both points are important, like it is a straight line passing through origin, because whenever there's a straight line passing through the origin, we say that the quantities are directly proportional. Means if you increase one quantity, the other quantity will also increase. If there was a graph between the force and the length, so when we have a graph between force and length, force on y-axis or length on x-axis, and the graph is not starting from origin, so we can say, even though it's a straight line, but we say it is not directly proportional. Why not directly proportional? Even though it is a straight line, but it is not starting from origin. So for a directly proportional quantities, it must be a straight line passing through the origin. Calculate the spring constant like force per unit extension or spring constant. So to calculate a spring constant, you can take any point on this linear region, any point. Like you can take the last point. If I take this point, force is 100 and extension is 40. So if we want the spring constant, it is force divided by extension. So 100 divided by 40, which is 2.5 Newton per, because extension is in millimeters, so Newton per millimeter. The limit of the proportionality is reached when the extension was 50. Continue the graph and show how the spring behaves when the stretching force is above 125. So till this point, it is obeying the Hooke's law, but then they are saying, so as I mentioned, if it crosses the elastic limit, how we complete? We make a curve towards the extension axis. If the same graph was there, if there was a force on x-axis and extension was there on y-axis and it was obeying a Hooke's law, and the question was, now it is not, it crosses the elastic limit, so we'll shift it towards extension axis. So remember, you have to diverge or bend towards extension axis. Another spring is having a smaller value of a K, and it follow the Hooke's law till 80 millimeter. So if you want to draw for a smaller value of a K, like a small force is needed to produce an extension, so it will be like this. But if the graph was extension on y-axis and the force on x-axis, then it will be, for a smaller value of a K, it will be like this, opposite. So if extension is on y-axis, this will have, the one which is steeper will have a smaller K, and the one which is having a smaller slope will have a larger K. For force and extension graph, the one which is steeper, like force on y-axis and extension on x-axis, the one which is steeper will have a larger K, and the one which is having a smaller slope will have a smaller K. So it depends on which axis we are taking the force and extension. In question 4, figure 1.1 shows an apparatus that may be used to compare the strength of the two springs. How the masses produce a force to stretch the spring, because masses are acted by a force of a gravity will act on the mass, or masses will have weight, or there will be a weight of the mass. The weight of the masses will cause an extension to the spring. Explain why the force, all forces are vector quantity. Why forces? Because if a quantity is a vector quantity, because it has direction and size, or a magnitude, you can say. So two springs are there, force on y-axis and extension on x-axis. So which spring will have a higher value of a k? So higher value of a k will have a spring, will be spring 1. And the lower value of a k, that is spring 2. Why? Because if force on y-axis, extension on x-axis, the one which is steeper will have a higher value of a k. The one which is having a smaller slope will have a smaller value of a k. State which spring is more difficult and quote the value from the graph. So which spring is difficult? Spring 1 is difficult, and how you can quote a value? Like you can say for a 10 Newton force, for spring 1, it costs 12 centimeter. When we apply a force of 10 Newton on spring 1, the extension of a spring 1 is equals to 12 centimeter. But for spring 2, the same 10 Newton force can cause extension of 17 centimeter. So you have to quote these values. And it's not like 10. You can take any, you can take 15. Like 15 Newton is causing extension of about 19. And here 15 Newton cause a greater extension. So spring 1 is difficult to extend because smaller extension is caused by the force as compared to spring 2. On a figure of spring 2, mark a point, limit of proportionality. So limit of proportionality is like you can put your ruler or the scale on the graph, the last point where it appeared to be a straight line. So last point where it appeared to be straight, that last point is the limit of proportionality. And why we call that as a limit of proportionality? Because you can say that till this point, extension and forces are directly proportional. Or force and extension are directly proportional. Then use a graph, find the difference in extension of a two spring when a 15 Newton is applied. Like how much is the difference in extension when we apply 15 Newtons? So when we apply 15 Newton for spring 1, the extension is 19. For a spring 1, the extension is 19 millimeter. When we apply the same force of 15 Newton on spring 2, the extension is 25. They did not ask the extension for each, they're asking how much is the difference between spring 1 extension and spring 2 extension. So what is the difference between spring 1 and 2? So it will be 25 minus 19, which is equals to 6 millimeter. Is it clear, this one?
Yes, sir, clear.
In question 5, a spring with the original length of 3 centimeter. So there is a spring which was having an original length of 3 centimeter. Without any load, the length was 3 centimeters. When a load of 8 Newton is applied, the length of the spring is 5 centimeter. Assume that the limit of proportionality has not been reached. Calculate the force needed to extend to a total length of 6 centimeter. Like the question is how much force is needed so that the total length of a spring becomes 6 centimeter. So that is the question. This question can be solved by two ways. Either you can use a formula to solve or you can use a ratio to solve. If you use a ratio to solve, like we know force and extension are directly proportional. When the force is 8 Newton, how much is the extension? It was 3 become 5, so it means the extension was 2. And if the force is x Newton, how much is the extension? Originally it was 3 and now it is 6, so the extension is 3. Because 3 becomes 6, so it means the extension is 3. We just cross multiply. 8 multiplied by 3 is equals to 2x, or 8 multiplied by 3 divided by 2 is x. So 24 divided by 2, that's equal to x. So x is equals to 12 Newton. This is one way. You will get 12 Newton as an answer. There's also another way you can use a formula to get the same answer. First, what we'll do, we'll find the value of the spring constant. We'll find the value for a spring constant by using a formula that the spring constant is force divided by extension. So force is 8 and the extension is 2. So spring constant is 4 Newton per centimeter. After getting a spring constant, we again use the same formula that spring constant is force divided by extension. Spring constant, because spring obey the Hooke's law, so spring constant is 4. Force we don't know, and extension, when a load is applied, the new length is 6 centimeter. So how much it is extended by 3? So 3 is divided, other side multiplied. So 3 multiplied by 4, that makes 12 Newton. So the extension is, the force is equals to 12 Newton. So either you can solve by using a formula or you can use the proportionality relation. Then a student investigated the stretching of a spring by hanging various weight from it and measuring the corresponding extensions. The results are shown on figure 3.1. Plot the points for these results. Do not draw a line through the points yet. So first thing, you have to just plot the result like it is 1 and 4. 0, 0 is there. Then 1 and 21. Then we have 40 and 2. 3 and 51. So each 10 boxes equals to 20. So each box equals to 2. So this will be 21. This 40, 51, 3 and 51. This will be 51. Then 4 and 82. 5 and 103. Somewhat here. So these are the points. Then the student appeared to have made a mistake in recording the result, which results appear to be inaccurate. By looking at these points, which point does not appear in the same region? Like which point appeared to be outside? So the point at 3 Newton, which caused an extension of 51 Newton, 51 millimeter, that is appeared to be wrong. So this point is not correct. So you can mention a point at 3 Newton. Then ignoring the incorrect draw, we did that. State and explain whether the spring obey the Hooke's law. So you will say yes. Why you will say yes? Because it is a straight line passing through origin. So whenever it's a straight line passing through origin, it means it is obeying the Hooke's law. Describe how the graph might shape if the student continue to add several more loads? Yeah, there is one point it does not obey the Hooke's law. So that point is appeared to be inaccurate. Like that is a mistake done by the student, not about the spring. Spring was, if the spring was not obeying the Hooke's law, then all the points appear to be out of the range. Like if the spring is not obeying the Hooke's law, then what should happen? First, it will appear to be straight line, and then the points appear to be like this, become curve. But what happened here, that all of the points are lying on the straight line except one. So it means that is the mistake of the student. That's not because of the spring. So if you want to continue the graph that it obeys, so because extension is on y-axis, so if extension is on y-axis, we'll continue diverted, like increasing a force, extension will increase, but not with the same rate. So it start to appear to be curve. Don't make exactly vertical, but just a curve deviated towards the y-axis in this, like, or extension axis. A student estimate that if we hang 45 Newton, the spring extension will be 920. Why this estimation may be unrealistic? Because what might happen at 45 Newton, that it crosses the elastic limit or spring might deform. That's why it is unrealistic to say that it will follow the Hooke's law. Or maybe the spring. No, curve, whenever you are making a curve should bend towards the extension axis. For a spring, if the side where you have extension that I mentioned in the beginning, for example, if you have extension on y-axis and force on x-axis, and first it is obeying the Hooke's law. So first it will be a linear part, it is obeying the Hooke's law. And if they say that beyond the elastic limit, so the curve towards extension axis. If the graph was a bit different, if force on y-axis and extension on x-axis, again it will be a straight line, but this time it will curve towards x-axis. So it's like curve towards the extension axis. If extension on y, curve towards y-axis. Extension on x, curve towards x-axis. Is it clear, this question? So these are some questions from exercise Hooke's law. So you have to solve this exercise and submit as a weekly homework.